Hi everyone, it's me, Yeti Italian Gamer Joe, and I am here to bring you the first round of programming tutorials. I am really excited to do that. Also, this is the first time that I'm unveiling the PNG stream of Yeti Italian Gamer Joe. It's basically still me. I'm not really portraying a character or anything, but I think it would be more cute and fun to show more of the programming side of things and less of me. So I'm really excited to unveil this brand new style of streaming that I'll be doing, aka PNG streaming. The PNG streaming is brought to you by Reactive by Fujitech. They create Discord streaming with PNG photos. So if you don't want to actually display yourself, you can create an avatar or digital character and have that be in place of yourself. So you'll be seeing a lot more of Yeti Italian Gamer Joe for these programming tutorials, and I'm really looking forward to getting started with showing you all more of how to do them. The engine that we'll be working with exclusively will be Construct 3, which I've done before in the past, and I'm really looking forward to continuing using Construct 3 for future game dev. So why don't we get started? Last week, I released a video on my YouTube, and I'm gonna go and pull that up now. So the video that I posted is called Parody Fan Made. What if Nancy Drew was a top-down video game? So I'm gonna go ahead and play this video now. As you can see here, you got Nancy. She's walking around the office from Message in a Haunted Mansion. She can examine things like desks. She can walk around and look at the fireplace. She can go into the secret passageway. And finally, she can go look at the mahjong table. So that is the video that I created, and I accidentally opened one of my past videos. Let me close that. So you're probably all wondering, how is it possible? How was I able to do that? That was all possible with the Construct 3 game engine. This is a very powerful game engine that I highly recommend that you use. Also, welcome on in, Candy Girl. But yeah, this is a really powerful game engine. It is free if you register with an account. There is pricing as well. There is plans that you have to go through. It's $19 per month, $119 per year. There are some pretty cool benefits you get with the personal edition. As like you kind of get more the access to all of the features, but you can totally use the free version and have pretty much the same stuff. I would personally use the free version until you feel more comfortable with the premium version. All the tutorials that I will be giving will be using the personal edition, but I made it possible so that if you have the free version, you can still view all my projects with the free version. If by any circumstance that you open one of my projects and the free version doesn't allow for something, let me know and I'll try to find a workaround. So let's go ahead and jump in. So this is the Construct project. I zoomed in my project so that you can see more things much easier. So if you want a more in-depth Construct tutorial, I can definitely do that in a future stream, but I'm going to go in with the knowledge that perhaps you are familiar with Construct from one of my earlier streams a while back, from over a year ago, and I'm just going to kind of like walk through this and have some fun with it. So as you can see here, we have a layout called the library, and this is basically the entire room. You have this sprite, this background sprite, which is basically the office, and I can basically like move it around. I'm gonna go ahead and undo what I just did there. That is located on layer 0, so I'm gonna go ahead and hide these layers. The office is located on the bottommost layer. So if you think of layers like a cake, the bottommost layer of that cake is the base, and the base concludes the actual library itself, And then we have Nancy herself, which is that character Nancy right there in the middle of the screen. Those are the only two objects that we have in the room. If you go one layer up, we have walls. Walls are just basic sprites that have a transparent layer. So if I go ahead and use my dropper tool, notice that the alpha, or the transparency, is set to 100 out of 255. What that is basically, I'm using the paint bucket, I'm setting it to blue, and then I'm changing the transparency to 100 so that it becomes see-through. As you can see here, I started putting those square boxes all over the room. But then what I did was I created a layer called walls, and then put the walls all over the room. And then I added a behavior called solid. What solid does is that it makes the object impassable to other solid or non-solid objects. So, for example, if Nancy is solid and the wall is solid, the game knows to have Nancy bounce off the wall. So that's pretty much what it's doing. So, for example, if I launch the game and I load it, if I have Nancy walk up to a wall, she will not be able to pass through that wall. So if we have her walk to the side here, she won't be able to walk to this part of the wall, or she won't be able to go through it at all. So as you can see, same thing, you can't go through the walls. Nancy knows not to go through the dimensions of the brick wall. So, super convenient there. The next layer that I have is called a hotspot layer. So if we go ahead and hide all of the walls and just show the hotspots, also this needs to change. I'm going to put that in the wall layer. Hotspots I made yellow. So this is basically what I did was I grabbed a color picker, I set it to the color yellow, did a transparency of 100, and basically set it to the color yellow with a transparency layer so that we can see behind it. Yellow boxes are not solid. So Nancy in the game can walk through these walls. So for example, if I make this really big, Nancy can still walk into it. I'm using the arrow keys, which don't have the animation set up to it, but Nancy can still walk through a hotspot. And I did that on purpose because if the player is trying to access a specific part of the room, they need to have, the hotspot cannot be solid. The player should not bump into a hotspot. They should be able to walk over the hotspot. In certain places that included the hotspots are the mahjong table, like right in front of it. I probably could have done the whole table if the player walks along the sides of it. That works too. I did the bookshelves. The desk has like a hotspot area. The fireplace has a hotspot area. And then I had the sacred passageway being a hotspot area. I could also increase the hotspots, like the hotspots like actual length or width. So for example, if I make it this big, Nancy is more likely to notice that the hotspot's there. So like as you can see here, when Nancy walks into those hotspot areas, she notices these locations much quicker than she were to if I lowered that hotspot area. So that's pretty much how the hotspot system works. Nancy has to walk into a hotspot in order for her to notice that it's a hotspot. And those are the basic 3 layers of my system. You have layer 0, which is just a default layer, and that's the image of the library, followed by Nancy herself. You have the wall layer, which is the blue transparencies that you see across the screen. And then finally, you have the hotspot layer, which is the layers that you see that are see-through layers that the player can go through. So that's the very basic core of what you're seeing from the video and the whole breakdown of it all. So now that you've seen that, now we're going to take another step further and we're going to go into some more of the programming logic of, how does a hotspot work? How does Nancy go from walking up to a hotspot and seeing that question mark symbol? And if you press the E button, how does that bring the player from one room to the next? How can the player click on this back button? If Nancy goes to one thing over here, how does the game know to zoom into that computer? how can Nancy animate like this? When she walks to the right, how does it know to animate? If when she walks to the left, how does it know to animate? What should Nancy's resting position be? Should it be to the right? Should it be to the left? I have it defaulting her resting position to the right. Nancy's idle animation, where she's just kind of like swaying back and forth. How does that possible? We'll be explaining that as well. So those are the next steps that I'll be talking about, and we'll be jumping into that right now. So I'm gonna go ahead and close that. So first things first, making sure you have all of your resources. So in order to create the transition from the main area that you see here to the fireplace, or to the secret passageway, or to the mahjong table, you need to have the images for that. I own a copy of Nancy Drew Message in a Haunted Mansion, so I was able to go into the game and print screen the images and then pasting them into Microsoft Paint. I then cropped the images and was able to save them that way as PNG files. So that's pretty much what I did there. In order to get the images into Construct 3, what you have to do is you have to go to Add New Object Type, set it equal to a sprite, name the sprite accordingly. Usually for backgrounds, I do BG underscore and then the name of the image. So once you do that, we'll go ahead and select this one. What you'll do is you'll have this window that will show you the paint editor window, followed by the sprites. The reason why they're called sprites is because sprites are meant to be animated, and sprites can have multiple sprite sheets. You can also have animations, and then each animation can represent a different picture. What we're going to do is so in order to get that image on the screen, you have to use the open button, which will take you to that specific area, which will then show you the image you're looking for. In this case, I already did all the work for us, and as you can see here, I created a new animation for each area that Nancy goes through. We don't really have to worry about the speed or the looping or anything, but basically each area that Nancy can visit is its own animation, and then it gets changed through each area that Nancy visits. So for example, let's say we want Nancy to look at the desk. I have a layout that I created called desk. I'm gonna go ahead and zoom out. Welcome on in, Guava. So you're probably wondering, how is it possible that this image appears? So I'm going to go ahead and remove the GUI and remove the hotspot layers and just show you layer 0. So inside this layer, what happens is you have this image, which is the BG library, which I probably should rename to something more generic. But once you put the BG library in here, the default animation is going to be bookshelf left, which is not the desk. So let's say I load the screen. If Nancy were to go over to the desk and inspect it, notice how she's checking out the bookshelf. That's not proper programming. So we're going to go ahead and close this. How do you change this animation from the bookshelf to the desk? Well, if you click the sprite and you scroll to the bottom in the properties editor, you'll see initial animation. Change it to desk, and there you have it. So you upload the image using the open tool, set the animation name here. You can also add new animations or new sprites as you see fit, but that is how you were able to add the desk in there. Let's say, for example, you want to go one step further and you want to add the computer. You can also upload I also uploaded the screenshot of the computer's login screen. I'll explain in a moment how we get from this screen to this screen. Just like the library layout where we have the walls and the hotspots, I did the same exact thing here. But in this case, there's no walls. We just have a GUI and we have hotspots. So let's look at the GUI. So the GUI is basically graphical user interfaces. GUIs in this situation would be something like what you would see in a classic Nancy Drew game. That's correct, Guava. This is Construct. So if I were to go ahead and just type in Construct, or not Construct 3, sorry, Nancy Drew Message in a Haunted Mansion, Let me look up the gameplay. As you can see here, the GUI, or the graphical user interface, would be everything around the gameplay area. So you have the menu button, the question mark button, the inventory sliders, the text-based user interface that has the scroll button, the icon of the cursor, and the pretty background the game is surrounded by. So that would be what the graphical user interface would be when you're looking at video game development. So basically, a GUI is just the interface of what the game would look like. If you go into Google and you type in video game GUIs, you'll also see lots of examples of video game GUIs. So this is an example of a touchscreen video game GUI. You'll see some more video game GUIs. A lot of these are purchasable. So if you go to various websites, you can actually purchase a lot of these GUIs for your own game development. One website that I personally recommend is craftpix.net. You can buy them individually, or you can pay a monthly subscription and you can get all of their GUI packs for free, as long as you do attribution where if you just mention that you got it from craftpix.net. They have tons of different GUIs that you can choose from and download for your own personal games. That is what I recommend. That is correct, Guava. So the GUI is a separate layer from the background. So if I were to uncheck the layer for the background, which I usually just call layer 0, but you could rename it to whatever you would like it to be, the GUI still exists separate from the rest of the background. So the GUI is independent of the actual background itself. The next layer that we have above the GUI would be the hotspots themselves. So remember when I mentioned that I have a yellow hotspot box? So this is the yellow hotspot box that I created, and I made it multi-purpose. So not only is it being used for hotspots that Nancy can walk into, but it's also being used as a hotspot for the player to touch or to look at. So let's go ahead and make it visible. You can see that I have two hotspots available. I have the hotspot for the computer, that if the player clicks on the computer to go to that computer scene, and then I have a hotspot located on the back button, which I'll be going into very shortly. So this is pretty much how this scene works. And if I were to go ahead and open Fireplace and zoom out a little bit, it works the exact same way. You have the GUI, bookshelf left, same thing. Secret passageway, zoom out a little bit, same thing. The mahjong table, same thing, and so on and so forth. It's all the same user interface. It's all the same GUIs. It's all that magical good stuff of video game development. So why don't we take a step back, go back to the main scene, which is this scene right here of Nancy walking around the desk and kind of just having some fun looking around. I mean, I'm imagining this is how Nancy probably, did it in the game if this were a top-down game. I'm imagining just Nancy walking everywhere. I even added a Nancy run command so that her running speed goes faster. But yeah, so anyway, let's go into that logic. How does Nancy able to move like this? How is she able to go from up and down and left and right and diagonally? How were we able to do that? So I'm going to close this. So every construct page has an event sheet. The event sheet that I have is called library, and this is the event sheet that's associated with this layout. So let's go ahead and open that event sheet. The event sheet has so event sheets are sequential, and they're sequential lists that start from the top and make their way to the bottom. And basically they have they run sequentially, and they're based on certain conditions that must be run. So what happens, I have an event sheet here called on start of layout. That runs when this scene loads. I have a function that's getting run called call player position with a parameter of get. What that means is that I'm when the player visits this scene or revisits this scene coming back from a certain first person view, I'm checking to see if it's our first time in the room, or if we are coming back from a first person situation. If the player's X and Y variables are set to 0, meaning it's our first time in the room, then what we're doing is we're going to call the player position, and we're basically going to we're basically setting the player's position to the center of the library. That's all we're doing. So if this is our first time in the room, then we're going to set the player's position to the library. I'll go into this function shortly. One thing, so another thing that you'll notice is my library data screen has something called an input manager. This is something that I personally created, but it's very important in video game development. Unity has something like this. They program their own input managers. Lots of game development tools will have some sort of like input management system that handles touchscreen, controllers, mouse and keyboard, game pads, and so on and so forth. I created my own personalized input manager, and we're going to go inside it. So input manager is its own data sheet, and I'm going to explain how this works. So the library event sheet, it only has 2 events, but I included input manager. What that means is that this input manager is an independent coding sheet, and I can insert it into any one of my event sheets anywhere in the game. So for example, if I'm looking at the desk, the event sheet is input manager. If I look at the computer, the event sheet is input manager. If I look at the bookshelf, the event sheet is input manager. So basically, the input manager is kind of like an independent event sheet that kind of like functions on its own. If you want to have basically, if you want to have more functionality on this screen, you probably will need to make a custom event sheet that's separate from input manager, and then you'll have to do what I did for library where you include input manager. But if you're doing a very basic screen that just shows a picture followed by a back button, you probably don't need anything other than the input manager. So why don't we jump into what input manager actually is and what it does. So input manager, what I'm doing on the start of the layout, which is another construct event, I'm setting the Nancy sprite to idle animation. So you're probably wondering, well, what is that? So let's go ahead and open the idle Nancy animation. So this is a Nancy Drew sprite that I found from the CraftPix website. It's not actually Nancy, it's just a woman with brown hair wearing a suit. And I downloaded this, I imported it into Construct using a strip, which basically what you do is if you have a sprite sheet that is separated into like quadrants, you can import it into Construct, and Construct will do the work for you. It will automatically animate it for you, and it will also automatically make the sprite look like this. So when you hit the play button, it'll actually animate it for you. It's really, really convenient. My speed is set super low, so you're seeing a very like slow sprite because this is the idle animation. Exactly. You're dividing a video into scenes. Exactly, Guava. So that's one of the first animations. I then add animation, and I created another one. This one is the Nancy walking animation, and as you can see here, I broke it frame by frame. Again, this was imported into the system. If you have a frame that you're importing, you can import from separate images, or you can import from like a comic strip that shows you the individual pieces, depending on when you, let's say for example, I'm on CraftPix and I go to sprites and characters, and I see something like this. This is what I'm talking about. So if you're on this website and you download a sprite sheet, you'll probably see it like this, where it's like a comic strip of characters. What you would do is you would download this, you would go to Construct, you would add a new animation, name it, and then down here you would do import frames from strip, and then the system knows automatically what pieces are involved in the strip, and then it will animate it accordingly, which is really convenient. It's really smart, and it's really cool being able to import any of your sprites in here and just immediately start getting to work. It's really, really convenient. I also have an unused investigate, which is basically Nancy just putting your hand up in the air. The the way it's exported, it places everything out. Exactly. If I really wanted to, I could probably do this backwards, where I could have Nancy tap it instead, where she goes downward and does a downward tap instead. It's kind of like up to you how you feel and what's more comfortable. And then here I have the walking left animation. When it comes to animation properties, you want to make sure that you have a specific speed, that you're looping the animation so when it's done, it goes back to the first frame again. Because if it doesn't, then what ends up happening is Nancy will just float. And then same for the rest of them as well. So that's the animation. So what you're seeing here is on the start of the layout, I'm setting Nancy's animation to idle, which basically means have her kind of like sway slowly. If we go back to the library layout for a second and look at this Nancy sprite in the environment, you're going to see something called behaviors. So I set Nancy's behavior to solid because she's a solid person in the room. She's not jelly. She's not goo. She's not like passable. She's not a ghost. She is a solid object in the environment. So we have to give her the solid property. Another behavior that I gave Nancy is something called 8 direction. 8 direction is a type of physics movement. So video games have physics, and one of the things I love about Construct is that Construct pre-programs physics for you. So if you want to create a game that has a character that moves in 8 different directions, Construct already programmed that for you. If you want a game that involves controlling a car, Construct already programmed car controls, including accelerate, deaccelerate, steering wheel controls. You can do custom, you can do orbit, where if you want, a player character to orbit around something, tile movement for like tile games, platforming movement like Super Mario Brothers. The really, really cool thing about adding these behaviors, turrets, like pathfinding. So if I were to like click on somewhere for Nancy to go, she'll automatically walk there. And she'll move around obstacles. What makes Construct so convenient is that all of these physics programming, all these physics pieces, all the mathy stuff, Construct already did it for us. So what makes it so convenient is that all you have to do is pick the physics that you want to add to the game and then just hit the add button. And it's already programmed for you. You don't even have to worry about any of the math, any of the special stuff. You just get to tweak it a little bit and it's good to go. So I added the 8 direction movement for Nancy, and what that does is that it adds this 8 direction piece. You can tweak the physics from there. That is correct. So if I were to select Nancy, now that we have the 8 direction movement, I'm given a bunch of little controls here. So the max speed that I'm giving Nancy is 300. That means that she moves 300 pixels, I believe, per second. It tells you right here the maximum speed in pixels per second the object can travel at. You also have acceleration and deacceleration. Try to think of that like a car. Usually I do something like 9999 and then deacceleration 9999. The reason why I do that is because in real life, cars have to accelerate to get to a certain speed. But in video games, thank you for that redemption. I really appreciate it. So in video games, the acceleration and deacceleration isn't really applied here. So what ends up happening is if you're controlling a character, you want the acceleration to go as quickly as possible, and then same with the deacceleration. Genies, hope you have a great night. Thanks for coming in. So, kind of like in Super Mario Brothers, how Mario, if you were to click left, moves extremely quickly. Let me show you what happens if the acceleration is set to 100. What ends up happening is Nancy slowly starts moving. Notice how her pace slowly quickens. So we don't want that. We do not want that for our game. So that's why I set it to 9999, which is it's not really a maximum, but it's fast enough. Deacceleration, what happens if we do that for deacceleration? So let's say Nancy has it. So what ends up happening is we kind of have like this asteroids approach, or like this rollerblading approach, where it looks like Nancy's walking on rollerblades or something. I would not advise this unless Nancy is on ice or something, or she's like supposed to be sliding like this. But yeah, but this is what happens if you make the deacceleration really, really low. It makes Nancy look like she's on, yeah, like Lava was saying, it makes Nancy look like she's on slippery socks and she's sliding her way across the library. That's definitely not something we want for the game. So you want acceleration to be you want the deceleration to be very high to make it so that Nancy, when she runs and walks, that it's very consistent. Notice how there's no like deceleration, there's no acceleration. Nancy's always walking and running at the same speed, and she's stopping at the same speed. It would then have to stop at the rug. Exactly, right? So that's pretty much what's going on with those two. Directions lets you choose if you want up and down only, left and right only, 4 directions, which is up, down, left, right, and then 8 directions, which is kind of like a compass. So you have like north, south, east, west, and then you have the compass directions like northwest, northeast, southwest, southeast, and so on and so forth. Default controls, what that means is arrow keys control movement. Otherwise, you have to do simulate control action, which I'm reading down here. I'll explain that in a moment. Allow sliding means if enabled, moving along sloped obstacles allow sliding rather than stopping. So I'll try to explain that. So let's say, for example, I rotate this box and I make it like this. And just for the heck of it, I will make hotspots visible initially. So let me go ahead and set this to initially visible. Wait, they are set to initially visible. Oh, wait, here we go. Okay, so when I get this room started, wait a minute, I thought I set it to visible. Hotspots, initially visible, initially interactive, initially visible. Why isn't it visible? Let me double check if I hit it. No, I didn't hide it. There we go. Okay. So, what sliding does is if Nancy is in front of a sloped wall, she'll go up the wall and slide up it. So that's what's going on here. So she's sliding up the wall. Where if I turn off sliding, I believe she won't do that. So let's try that real quick. Yeah, notice how she's not sliding up the wall anymore. So this is super convenient if you have like stairs, or if you have like some level. So if there's like some kind of like distinction between like areas that are higher or lower than others that are diagonal, then I would do allow sliding. So let me just show that again. This is what it looks like when you allow sliding. It makes it so that if Nancy is at maybe like by a staircase, it'll make Nancy look like she's traveling up the staircase. So it's super convenient if you have like a side-scrolling game, or if you have areas, like I said, that are diagonal that need to be done that way on purpose. But yeah, that's pretty much what that does. Let me go ahead and okay, so that's what I was doing wrong. Okay, so let me go ahead and turn off the visibility for all of these parts of the room. Perfect. So here we are back to the way the room originally looked. If the wall is vertical, does it know what direction to slide in? So if the wall is vertical, let's check that really quick. So I have allow sliding turned on. I don't think it slides. Let's check. Or maybe it just defaults to down. Let's see. So, I wonder, I'm not really sure about that. I've never tested that before. So let's see. If we have Nancy just coming in hot, it's having her stop. But if you happen to be near the top of it, it slides upwards. And if you're near the bottom, it also, let's see, it doesn't slide at all. So I think that's just a physics thing. It's just, yeah, I think you just have to kind of mess around with it and test it. But if it is vertical, it seems to be taking like the top part of it. If I'm near the bottom of the desk, for example, it goes down. If I'm near the top of the desk, it goes up. So it seems to be based on the location of where Nancy is in her environment. It goes down if she's closer to the bottom. It goes up if she's closer to the top. Same with this passageway. If she's closer to the bottom of that wall, she'll go up. If she's closer to the top of it, she'll go down. So it actually is pretty convenient in a way where If you don't want if you don't want Nancy to get stuck in the wall here, it'll just automatically slide her up the wall. So that might be really convenient that they thought about that. So that's and then let's see, was there anything else? There's enabled, which decides if the behavior is enabled or not. And then there's default controls, which again, this is the arrow keys. You would control with the arrow keys, but if you want to do WASD, I'll explain that next. So by default, the eight control movement is with the arrow keys, and as you can see here, Nancy's not being animated right now. So I remapped it to the WASD keys on the keyboard because that's the default controls that we would be using, and I would turn off the functionality for the default. So let me go ahead. So if I were to uncheck this, what would happen is I'm using the arrow keys and nothing is happening. Nothing is happening when I tap the arrow keys because you have to move with the WASD keys. So how is that possible? How is that happening? We're going to jump into that now. So let's go into the input manager. So in event sheets, you have something called comments. So I added a comment called controls, and basically this section from line 2 to line 11 are all things that pertain to controls. So the first control that I have is an event called keyboard is down. So what I did was I separate all my objects into folders, and I have backgrounds, sprites, and system objects. In my system objects, I have a keyboard and mouse. So I did keyboard, and then I did key is down. What key is down, it tells you right here, test if a keyboard key is currently held down. There is a difference between pressed and down. I believe pressed is if it's like pressed down once, where down means it is down, like you are holding it down. The Construct website has a full list of what all of these mean, but we're looking at keyboard, and key is down is what we're looking for. So if the W key is held down, what we want to do is we want to I created an event, and what the event is that so what I did was I basically went and looked for the Nancy Drew sprite, which is right here. And then if you look through here, all of these things are little code pieces that we can do with Nancy. 8 direction, though, is the one we're looking for, and this is part of the physics that was pre-programmed for us. Simulate control is what we want, and what simulate control does is that it simulates it's basically you're basically telling the system to make it look like someone pressed up on the keyboard instead of what we did before. So we are simulating the control of the W key to up. Then what we're doing is we're setting the animation of Nancy herself to be set animations to SPR Nancy.animation name. W keys down, animation name. I have to double check that. SPR Nancy.animation name. I believe it's just whatever the initial animation is, but I'm not 100% sure. I'm going to double check what I did there, because that is something I think I need to double check. So I'll double check that in a moment. But if W is down, I believe it just plays what... Oh, okay. Okay, I know what this is doing. So it's playing whatever the current animation is assigned to. And the reason why I did that is because if Nancy is walking up and she's walking up facing the left, I made it so that regardless of which direction she's facing, it'll continue to use that animation. This is why you should always comment your code. So I'm going to put a little comment there saying if Nancy walks up or down, use whichever animation that's currently set. Commenting your code is always important, so always make sure to comment your code. Next, we're gonna so now what I'm doing is if the animation name is set to idle, then we're gonna just default it to walk left, which I'll explain that in a moment. The A key represents the left button, so we have an event that basically makes Nancy move to the left, and then we're setting her animation to walk left. The S key is down, so we have the same thing, and then I'm also doing comment Joe was here. And then I also have the same thing as up here, which is I'm going to go ahead and copy this comment and put it right there. So I explained that as well. And then the D key is for walking right. So I have Nancy moving right with the simulate control key, and then I have the animation to walk right. So we have W, we have A, we have S, and we have D. W is up, A is left, S is down, D is right. Then here's the next problem. What about when you release a key from the keyboard? Like if I were to push down D but then let go of D, what happens? If I push down S and then let go of S, what happens? So we need to have an event that handles a keyboard key being released. So I created an event called keyboard on any key released, have the sprite of Nancy's animation play from the beginning. Play the idle animation from the beginning. So what's happening here is it's basically just setting her animation to idle. That's all it's doing. And then don't forget, the reason why I'm not having like another action here of Nancy, the reason why I'm not like making her speed set to 0 or anything is because if we go back to the library layout and we look at her deceleration, it's already going to be set to 9999. So we don't have to worry about Nancy's speed or making her stop moving, because the behavior already knows that if there's no acceleration being handled, it knows to automatically deaccelerate back to 0. Or I guess in this case, back to 0. So what's next? We have to have some mouse controls. So let's say now we're inside the fireplace, and you decide that you want to click this back button. Well, you're not actually clicking the back button. You're actually clicking a hotspot that's in front of the back button. So the reason why I do this is because when it comes to video game development, specifically for like input managers and stuff, the way I design things, you shouldn't really be clicking on the GUI elements. You should be clicking on like a hidden element that is technically apart from the GUI. And the reason why we do that is because of simplicity and for convenience of maintaining your code. So what happens is if you click on a hotspot, what I'm doing is I have a left button event. I'm calling a function called hotspot clicked, which passes in a parameter of an action and a scene. So I'll explain that momentarily. This event is something called the shift key. So the upwards arrow, by the way, in coding is a shift key. So if the shift key is down, we're setting Nancy's speed to 500. This is basically if you want to give Nancy a turbo. So if you want Nancy to run, I create an event that basically makes it so that if the shift key is held down, we're changing Nancy's speed to 500 pixels per second instead of 300. And then if it's released, then we set it back to 300 again. So that's pretty much how the controls work. And now we're going to move over to the hotspots. So how does the game know that when Nancy walks up to a hotspot, that little bubble appears over her face, and how does it follow her? And then if Nancy does walk up to the fireplace, how does the game know that Nancy is here at the fireplace and not at the desk? Because if I go into the desk, Nancy goes to the desk. If I go to the fireplace, Nancy goes to the fireplace. If I go to the mahjong table, Nancy goes to the mahjong table. If I go to the bookshelf, which that one doesn't have an image, but if I go to this bookshelf, how does it know to go to those specific rooms? So when I created the hotspot, I created something called instance variables. So every object in your scene will have instant variables on the left here, and the way they work is that they are pockets of information that can be assigned to that specific instance. So as you can see here, like walls don't really have instance variables. Nancy herself doesn't have any instance variables. A lot of stuff in this room doesn't have instance variables. The only things that have instance variables are the hotspots themselves, which is what you see here. And the instance variables that I created are action, bubble, and scene. These are very specific custom instance variables that I created myself and I use for different purposes. So why don't we take a closer look at what each of these mean? And notice how, so I'll explain that now. I have a function called hotspot clicked. And the way this works is that it gets called when Nancy is either when the player is clicking a hotspot, or if Nancy pushes the E button down, or the player pushes the E button down, then I call this hotspot clicked event. So the way this works is this hotspot clicked function, and you can create a function by right-clicking and do add function. You name the function, and then you can also include a description and category. But once you create the function, you can also then add parameters, which is what I did, which is an action and a scene. But the way it works is that any input and management, any kind of hotspot event goes in here. So the way it works is if the scene is not empty. So for example, if Nancy walks up to this and the scene says fireplace, the hotspot knows to go to the name scene, go to that scene. Because what I'm doing is I'm setting the scene from the library equal to which scene, the scene name here. So for example, scene is set to fireplace, which means it will go to the fireplace. Scene here is set to desk, which means it's going to that desk scene. Mahjong table is set for the scene here, so it goes to the Mahjong table. Everything has to match up, otherwise it won't work. And that's pretty much how I have it set up there. So bookshelf left, bookshelf left. Because what you're doing is you're setting the name of the scene equal to that specific scene that you want it to go to. So as long as the scene is not blank, because if the scene is blank, the game doesn't know where to go to put the scene to. You're going to go to that scene. But then how does this function get called? So let's continue that. So now we're going to start doing some more deeper stuff, like with the hotspots. Because you're probably wondering, well, what about bubble and what about action? Like what does bubble and action mean? So I'll go ahead and start explaining this next. So if Nancy is colliding with a yellow hotspot, so if we're in the library and Nancy makes her way to a desk, or she makes her way to the fireplace, like what happens? So we have a system event, and the system is creating a bubble, a thought bubble, on the bottommost layer, and it's creating it at Nancy's current location. So we can access that by doing the name of the sprite, which is Nancy, .x, which is the x coordinate anywhere in the scene, and then we do the y coordinate, which is SPR Nancy.y. The reason why I do -20 is because when you're in a scene like the library, 00 is right here. It's the am I thinking that right? Yeah, 00 is like right here somewhere. I'm trying to get to it. But anyway, 00 is like right here somewhere. And then what ends up happening is the more you go right, the more positive it goes. And then the more you go down, the more positive it goes. But then the more you go left, the more less or negative it goes. Because the way it works, if you think about it, is you're going right and down on an axis. And the screen starts its pixelation from here, which is 00. So like 795.24 would be like right here, which is the x value of 789, and then -11 because we went down that many pixels. So basically, as you can see here, we keep going down. You can see my mouse position right here, which explains where I am on the screen and which pixel I am in. So for example, this object that I'm clicking, it's in position 520, 118, which is pertaining to the position right here, I believe. Or is it somewhere else? Let me double check real quick. It might also be the object's origin point. Yeah, let me change the object's origin point to 1 to 1 1. I think that'll fix it. So now, is it 5? 460. Yeah, okay. So all objects in construct have something called origin points. Yeah, an origin point. And the way that works is that it positions something based on where the origin point is located. So if I set the origin point to 0, 0, for example, the origin, I think the origin point has to be 1, 1. Yeah. So as you can see now, that little tiny dot there is the origin point. And what it's doing is that it's calculating the position based on that origin anchor point. Which in this case is the very, very tippy top left there. Before it was setting the origin point to like somewhere in the middle of the circle, which was like right there. But basically what's happening is it's calculating the position of the screen based on where that origin point is located. So anyway, oh yeah, and then it also screwed up the rest of my objects. I'm gonna undo my change there. So the origin point is somewhere in the middle again, which is totally fine. It doesn't really make a difference for what we're doing. But basically what I'm doing is I'm creating a special like thought bubble box, which is a custom image that I created. And I'm putting it on the x-axis of where Nancy is located, and then along the y-axis where Nancy is located, but then I'm subtracting 20 because I want to do it above Nancy's head. If I were to add 20, that would go below Nancy's head. If I were to subtract 20, that'll go above Nancy's head. And the reason why is because the further down you go, the higher the y-axis goes. The further up you go, the lower the y-axis goes, because the y-axis is really up here and the 0 starts there. So let me go ahead and show that off really fast. So if I go into the scene, notice the bubble. Notice how the bubble is positioning itself 20 pixels above Nancy, and we can position that bubble like higher up if we want, lower up. But the point is, we're trying to position it as high up as that looks reasonable for Nancy. The next thing we're trying to do is we are trying to animate that thought bubble. So if I go over to that sprite called SPR thought bubble, I have some animations for it. So none is default, which means we're displaying nothing. But then I also have blank, which is just a blank thought bubble. I also have puzzle, which is with a beautiful created puzzle piece. I mean, this gives Banjo-Kazooie a run for its money. I also have a shock puzzle piece, or a shock bubble, which is just a very basic exclamation point. A question bubble, which is what you've been seeing. The exit bubble, which basically shows like perfection, which shows like an exit room. Speak shows the 3 dots. And then happy shows just a very happy face. It's a very happy thought bubble. This thought bubble is just, it's really happy today. It's having a good day today. So all of these are basic animations for the thought bubble. I'm going to go ahead and close that. And what we're doing is so what's happening here is I have a sub event. And the sub event is checking the hotspots, the hotspot that was selected, that we collided with. It's checking its event, and what I'm doing here is if the bubble's event is set to exit, then we want to animate the exit bubble and make that exit bubble more prevalent. If it's set to question, then we want the question one to be more prevalent, which is what we did there. Another thing that I added, so let's go back to the library. So you need to have a rudimentary object in your scenes, by the way. So the bubble that knows to look this way, because the reason why the bubble knows to look this way and not like this big, which I'll actually show you now, is because you need to have the object in your scene so that the system knows how it should look. So as you can see here, the bubble is ginormous, and it basically like takes up the whole screen, which is not ideal. So what you want to do is you want to drag the object, the bubble, into your scene, and you want to like make it look nice accordingly, so that the system has like a template to copy off of. And so that's why we have it outside the scene, because it doesn't need to be visible to the player. So now what we're going to do is we are going to jump back into that input manager. Another thing I did was that I added a move to behavior to the bubble. So you're probably wondering, well, why do you need a move to behavior? Like, what's the purpose of this? So the move to behavior has a max speed of 500, not 499. I'm not really sure. It doesn't. It has the same acceleration and deceleration as Nancy, and the reason why we do that. So without an object, it just goes to it just goes to default size. So what I'm doing here is I have a move to object that has a behavior called move to. So I'll explain what that does now. So when the thought bubble gets created, what I want to do is, so the object, what ends up happening is, if Nancy collides with a hotspot, we're creating the bubble. We're creating it. While Nancy is still overlapping a hotspot, I want the thought bubble to follow Nancy. So what I'm doing is I clicked on the, what I did was I clicked the thought bubble sprite, and then if you scroll through all of the properties, you'll see something called move to, and then there's move to object. If you click this, I have it set to following Nancy only if she's inside that hotspot. And that's what I'm doing here. If Nancy is no longer overlapping the hotspot anymore, we're destroying it. So if she's overlapping the hotspot, then we have it follow Nancy. If she's no longer overlapping it, we destroy it. So if I go back into this scene, Nancy is in the hotspot, and notice how the balloon the thought bubble follows Nancy. As soon as I leave, it destroys it. Same thing with this one. It's following Nancy. As soon as I leave, it destroys it. This one, it's following Nancy. As soon as I leave, it destroys it. In the secret passageway, it's following Nancy everywhere I go. As soon as I leave, it destroys the balloon. So that's what's going on there. It looks for the hotspot. It creates it. It moves. It creates it here. It tries to follow Nancy here. And then if Nancy ever leaves that hotspot, it gets destroyed. What's next? So the next code I have is right here. So if Nancy is overlapping a hotspot and the player also hits the button E is my default interaction button. What I'm doing is I'm having the system go to the layout SPR hotspot.scene. I should probably fix this. What I would do instead, actually, for this is I would call the function hotspot clicked, and then I would make the action SPR hotspot scene. Well, no, I wouldn't do that, actually. I would I would do hotspot.scene. I would do that, and then this should be like a empty. So what I did was I changed my logic. So what I'm doing is, if Nancy is overlapping the hotspot and the E button is down, I'm calling a function called hotspot clicked, and then I'm setting the parameter to the hotspots scene, which I'll test that now. And then another thing that I'm doing, the other thing I'm doing is I have a function here called player position. What's going on here is this is a function that I created that gets and sets the player position depending on certain situations. So in this player position function, what I'm doing is I'm setting the player position to glob player x. Or let me rephrase that, actually. So this is the input manager, which is what we're currently in right now. But I have another event sheet called data manager. Data manager is basically my own created save space, and I don't mean like a safe space. I literally mean like a save space for all global information and global variables. And the reason why this is extremely important is because this is a place where you can store information about your game. So the last room you visited, the current background, the current position of Nancy on the screen, inventory objects, literally anything. So what I did was I created 4 global variables called glob player y, glob player x, glob last room visited, and glob current background. So the way that works is these global variables can be accessed anywhere in your project, but as long as you declare them once somewhere, then that's what you do with it. So basically, I have them in a data manager, and as long as you declare these variables somewhere, you can access them anywhere in your project. So now that we are seeing this, I'm going to move back to the input manager and explain this. So what we're doing is I'm calling the set parameter, and what that's doing is that it's setting the glob player x and glob player y to Nancy's current position. There's a reason why I'm doing that. So let's say, for example, Nancy walks up to the fireplace, but she didn't walk up to it like right here. She walked up to it like right here, or right here, or like right here, or right here. We as the player need to know the position, because what's happening is if the scene loads, you don't want the Nancy to be right here every time. Like if Nancy goes into the secret passageway and then click the back button, we don't want Nancy to be here again. We want Nancy to still be in the secret passageway. If Nancy's at the mahjong table and then we click back, like I guess that could work. But we want Nancy to be where we left her. If she's at the desk, it wouldn't make sense to have Nancy facing the office again. So like that's what's going on here. I'm making it so that when the player clicks the interact button or hits the interact key, what we're doing is we're calling this player position function with the parameter set. And then it's setting the position that Nancy was in to her current position. That's all it's doing. The next step that we're doing is and then the next step we do is that we leave the scene to go to where Nancy wants to go next. So if I were to go ahead and go to this library and I were to walk around here and I were to interact with it, and then hit the back button, the game knows that Nancy was there. So so you're probably wondering, like, how did we do that though? Because we set it, but then how did we get it? So in order to do that, on the start of the layout, what we're doing is, and this is for the library again, we're calling the player position function, and then we're passing in the parameter get. So what get is doing is that it sets the position of Nancy's sprite to glob player x and glob player y. So the xy coordinates are set to those global variables. The reason why I say glob underscore is because glob is short for global. So that variable in that programming is setting Nancy's position to our global variables, which we set in this function. Another parameter I created was set library with hard-coded values. What this is doing, if we go back to the library section, excuse me. So if the player was entering the room for the first time and the global variables were set to 0 for some reason, I'm calling the function set library, which automatically, and then I'm actually calling it twice. For get set and then set library. I could actually remove this line of code and just do it automatically. So let me go ahead to the input manager. So what I could do there is I set the position of the of Nancy to the new variables here. So I basically condensed my code a little bit with that. So let's see. So setting doesn't actually set the position of Nancy, because when I set, I'm assuming that I'm leaving the room. But if I really, really wanted to, I could do that. It doesn't really hurt anything. We're still leaving the room anyway, so it doesn't really make a difference. But we could do that as well. So let's go ahead and test our code. Let's go ahead and have Nancy right there. We hit the back button, and Nancy's back where we left her. We do it here, Nancy's back where we left her. Do it here, nothing happens because there's no room there. Do it here, Nancy's still back where we left her. So everything looks exactly the same, how we left it, and it's looking pretty good so far. So that's pretty much all the code for the for that input box, and for the getting setting and the hotspot clicked and all that. So we handled all of this in 23 lines of code. So it's actually not too bad at all. The back button is an image that I created. It's just a circular image with an arrow that I created. But yeah, very basic stuff. The next piece that I want to show is how do we go from the desk to the computer? So how does the player go from one piece to the other? So on this desk scene, you're going to notice the hotspot. So there's a parameter that I have here called scene computer. So if you go into your input manager, which is the one we have here, if you scroll all the way to the section right here, on left button clicked on hotspot, we're calling a function called hotspot clicked, where we pass in a parameter of SPR hotspot action and then a scene SPR hotspot scene. So what happened is if we go to this function, as long as the scene is not equal to nothing, then we go to that layout. So if I were to go to if I were to go to the desk and I were to if I were to click it, I'm setting the scene equal to an existing scene called computer, which is right here. And then if you were to click on this hotspot right here for the back button, I'm setting that scene equal to desk. If I were to go back and look at this one, I'm setting that scene equal to library. So it's really as easy as that. And then each of these scenes all go back to library. So as you can see, this is the Nancy Drew top-down adventure project that I created, and this is the whole rundown of how I was able to do it. What I'm going to do next is I'm going to create a new layout. I'm going to duplicate this layout, and I'm going to call it winter. And we're going to have some fun. So what I'm going to do is I'm going to delete our hotspots, delete the walls, delete everything in here. I'm going to also move this. I'm going to remove this as well. You were hiding from me, weren't you? So now what I'm going to do is we're going to have some fun and try creating something new. So I'm going to go ahead and add a sprite in here, and I'm going to call it BG Winter. And then we're going to go ahead and place it in the scene. I have a Craft Picks background that I found, and the background that I'm going to use, I believe, will be this one. But let me just double check it really quick. Yep, this is the one. So the winter scene that I have here is something like this. So when Nancy leaves the office, we're going to have her be outside this winter wonderland, and which I know it completely goes against the game, but we're going to do it anyway. And then what we're going to do first is we're going to have the scene like this, and we're going to resize it a little bit just to make sure it looks okay. And then what we're going to do is we're going to make sure that the layering is correct. So we want it on layer 0, which is the background layer. And then what I'm going to do is I'm going to right click it and do Z order and then have it set to the bottom of the layer. What that means is it's kind of like in Microsoft PowerPoint or Word, how if you right click something, you can send to back or send to front. If two objects are in the same layer, that's all you're doing. You're just making sure that something is set to the front of the layer. Then what we're going to do is we're going to have Nancy just like right here, just right outside the scene. I'm going to make her a little bit smaller so that she looks like appropriately portioned. Because look, right now she's taller than the door. So I'm going to go ahead and make her a little bit smaller like that. That looks good to me. So I think that looks appropriate. So we're going to put her here, maybe right outside this door. And then what we're going to do is we're going to just run this scene for a second. So as you can see, what it did was it set Nancy here. And the reason why it set Nancy in the middle of the screen is because we need a new event sheet. So I'm going to go ahead and create a new event sheet, and I'm going to call it outside. and I'm going to set this event sheet right here on the top left equal to outside. Now we're going to go inside the event sheet, and I'm going to do something called include event sheet. We're going to include our input manager, so that the game knows that hotspots and walls and all that stuff is included. The next thing I'm going to do is go into the input manager, and I'm going to do something called, I'm going to do a new get set, and I'm going to do set outside. And what I'm going to do there is I'm going to, let me go ahead and close others, and then we'll just go back to that. Input manager, okay, winter. I'm going to grab Nancy's current position. So her current position is 227, 494. We're going to go ahead and paste that in here. So that was the X value, and then 494 is the Y value. So there we go. And now what I'm going to do is when the scene loads, I'm going to have a function. I'm going to call that function. So I'm going to actually copy some code that I already wrote, which is for the library. And I'm basically just going to copy this same code. I'm also going to rename this to winter instead of outside. So on the start of the layout, we're going to get the player position, which is basically checking the, which is basically setting the position to glob player X, glob player Y. But we're not going to do that. Actually, no, we are going to do that, because if it's already set, we set it. But if the, and then we'll do is we'll just set this to set winter. I think it did. I'm thinking about this for a second. I'm actually going to temporarily get rid of that. And I'm going to, was it set winter? It was set outside. Okay, there we go. So we're going to do set outside. And we still have it setting there. Okay, so her position is there. On the start of the layout. Oh, oops. All right. I was editing the wrong code file. So step 1 to any coding, make sure you're editing the correct file. So let me go ahead and edit this file. So I'm going to make this set outside. And then I'm going to toggle disabled for this so that we don't run that code yet. And as you can see here, Nancy is outside. So Nancy is currently outside, and we have her running around outside in this beautiful winter wonderland. So how do we make it so that Nancy doesn't start flying upwards and have her on the mountain? Like, how do we prevent Nancy from going too high in the sky, or going into this forest? How do we prevent Nancy from doing stuff like that? Well, we already have functionality for that. We have walls. So I'm going to add the visible wall into the layout. And what I'm going to do is I'm going to have it probably set to like right here. Because if Nancy's moving upwards, I want it to be like in front of the door, but not too high up. So I think that looks appropriate. I'm going to copy and paste another one and do one like really similar right here. Do another one like right here. Make this one like pretty long, maybe like up to here. And then like one like right here, maybe above the door a little bit, and then do the same thing over here. So let's go ahead and test that. So as you can see, Nancy can't go up into the mountain anymore, but she can go here. She can go here. Maybe we need to move that one down a little bit. She can go there, and then she can go there. She can also go around it, which we need to fix as well. So let's go ahead and fix that. Let's make it so that Nancy can't go around it. So let's see. We're gonna fix it like this, and then we're also gonna move. We're also gonna fix it so that Nancy isn't too high, and then we're also going to make it so that the floor doesn't. We don't want Nancy to be like too too low because it won't really make sense. And then to prevent from Nancy from leaving the layout, I'm gonna set some walls that are outside the layout's view, so something like that. So I think this is pretty. I think this looks fine. I think this looks pretty good. I think this looks good enough. So as you can see here, Nancy is able to walk around the town, and she's able to make her way from point A to point B just fine without any issues. I think this looks good to me so far. I think that looks appropriate. So now that we have the walls, we're going to go ahead and set these walls. Oh, so one thing I need to do is I need to... I did not set the walls properly. So what I'm doing is I am selecting all my walls and then making them walls so that when the scene loads, you don't see the walls anymore. So now Nancy is able to walk through all of this, and she's able to go from point A to point B. We're also going to see if sliding works here. Oh, we did allow sliding. Okay. So the next thing that I want to do for this scene is I want to create distance. So I want Nancy to appear smaller so she's not the same size as the house. So that's something I want to do. Another thing I want to do is make it so that Nancy, if she interacts with this door, it'll take her back into the library. So what I'm going to do is I'm going to actually move Nancy over here, and I'm going to add a hotspot. And the hotspot is going to be in the hotspot layer, and we're going to put the hotspot layer like right here. And then I'm going to set it to for the scene of the hotspot. I'm going to set that equal to library. And then for action, we're not going to set that to anything. The bubble, I want it to be the exit bubble, so let's see how that works. As you can see here, Nancy is set here. It's set Nancy accordingly to that area. And then if you look here, it's setting us back to where we need to be. So if I were to, which is great. But now that we're in the library, let's go ahead and fix this so that this scene takes us to the winter area, which is outside. Let's go ahead and do that real quick. So if we do this, that sets us to the outside area here. Ooh, I do gotta fix that. I wonder what happened there. So, scene library. So we did set it here, and then this should have went to the winter, which it did. Let me try changing that so it doesn't set to exit. Okay, that looks good. Yeah, that looks good so far. I'm not sure. So let's see. The reason why I believe it's starting her here is something that I might have done. So let me check that really quick. Player position get set is equal to get. Player position get set is equal to library. So what I want to do there is we want to make it so that when Nancy leaves to go to the outside place, it sets her beginning location to like right here again. I'll have to think about that. I'll revisit that momentarily. Let's see. And then we have Nancy's starting position right outside the area here. So then if we have her go back here. Also, I just realized I'm going to have to fix that as well. It's another bug that I just found. So if you have the E button held down, but if you have it held down for too long, it actually like puts you through an endless loop. So that's another coding fix I'll have to make. But what we're going to do is we are going to make it... One thing I want to fix is I want to fix Nancy's size. So if Nancy's walking and she wants to go down there, let's make her smaller. So in order to do that, we need a hotspot. So I'm going to go ahead and copy and paste the hotspot. And then what I'm going to do is I'm going to do one hotspot for this, and I'm going to make it a specific action. So what I'm going to do is I'm going to make the action... I'll make the action called Small Nancy. And then for the scene, we'll make it nothing. And then for the bubble, we won't do anything just yet because there's no bubble interaction there yet. And then we'll do another hotspot, and then we'll have that hotspot be a little bit larger, and we'll call that regular Nancy. So let's go to the input manager, and what we're going to do is If Nancy is overlapping with a hotspot, collision with hotspot, we're having it create an object, and then if the bubble is exit, then we have it doing this. We have it setting a certain way. What I'm gonna do is I'm gonna add another event here, and I'm gonna have it set to the action. So if the action is equal to small Nancy, what I'm gonna do is delete this event entirely, and I'm going to find Nancy, and then set her size. If you look for the size property, set size. Let's try to find Nancy's original. So I think what you can do is you can actually set the size to Nancy's actual size right now. Dot width, and then we'll maybe subtract it like -20. Dot height -20. So we'll just like lower that size accordingly, and then for the regular Nancy, what we're going to do is we're going to go to the winter scene, and then we're going to get her actual size, which is right here. So we're going to go ahead and grab that size and go back to the input manager and set her width and height to its actual size, which in this case is that decimal place. You can get rid of the decimal places if you think it's easier for you. Let's go back to the winter scene and just double check it. So she's 85 by 85. So let's go ahead and test it. So here we are back at the winter scene. I'm going to go ahead and make Nancy over here, and I'm going to try to get rid of those bubbles too, because those bubbles are kind of obtrusive. So let's see if I can fix that. Exit. I believe I have a bubble for none, so let me see. Yeah, I do have a bubble for none. So what I'm going to do is I'm going to set the bubble to none so that the bubble doesn't even appear at all. And let's see, the bubble is still appearing. I wonder if I have to fix that by okay, so I think what I'm going to do is I'm actually going to modify, I'm going to refactor my code, and I'm going to have it set to, if the bubble is not equal to nothing, then set the animation equal to the hotspot dot bubble. So that's what I'm doing there, and what should happen is, yeah, now it works, and now Nancy's size is working, but it's not ideal. I think I need to fix it a little bit more. So I'm gonna put a little tiny space and make this larger, and make this a little bit larger. Welcome on in, Nerd Next Door VR. Hope you're having a great day. So what I'm doing here is I'm setting the hotspot to something a little bit larger so that it makes Nancy look smaller immediately. So here's Nancy's regular size, and then if we go over here, it's setting her to a smaller size. And then back to larger to smaller to larger to smaller. I think Nancy could be a little bit smaller, so what I'm going to do is make the Nancy sprite just a bit smaller. So instead of subtracting 20, we'll be subtracting 30, and then same thing here, we'll be subtracting 30. So to make it look like Nancy is walking off into the distance, I have her character set to something smaller. It doesn't look small enough. Nancy is still taller than the door, so we're gonna do 40 instead, and do it 40 as well, and continue testing. Welcome back, Lava. So we're outside again, and Nancy is smaller. Do you notice how she's bigger, smaller, bigger, smaller? So we have her height taller than the door. She was taller than the door. She's still a little bit taller than the door, but at least we have like a better size difference. Now it looks like Nancy is back to her smaller shape again. So when we go ahead and copy that and then do the same thing here, we could we're gonna do that same thing here where Nancy looks smaller, and then we'll have her look big again when she's here. So something like that I think would work fine. And then maybe like we'll have her be small in this specific part, and then we'll have her look big again when she goes there. So let's go ahead and test that. So let's make Nancy run across the screen to the opposite side. We'll go full screen, Look, Nancy is a little bit too small, so I might have to do like a medium Nancy because she looks like a. I mean, this is like child Nancy, so I think we need to fix that a little bit. After oh yeah, and then this I think it's more appropriate, but we might need like a medium Nancy here, or maybe just the regular Nancy. Maybe how does it look if I just do like a regular Nancy? Let's see how that would look. So, let me copy another one and put one right here just in case the player decides to like leave a little bit. So let's have Nancy run across the screen and then make her tiny, make her big again. I think she looks fine. We can make her a little tall. But yeah, so, oh, wait a minute. She was upside down. Why was she upside down? Okay, so that's actually a very interesting gravity flipped on Nancy. So in order to fix that, what you would have to do is you have to go to this, and then you have to make sure the angle is set to no. And then I think for the sliding, we have to... Let me try that really quick. Yeah, no, it's definitely an issue. Yeah, it's setting her size in a weird way. I'm trying to think why it's doing that. So it's definitely a physics problem, and usually when you set the angle, that fixes it. But I wonder if we're gonna have to fix that as well. So the current angle that she is in is 0. So what I'm gonna do is if I go to the input manager and I do the small Nancy, what I'm gonna do is pull that up, go to the Nancy, and then set her angle to 0, just to make sure that she doesn't flip. Let's see if that fixes it. I hope it does. It actually made her even tinier, and then it flipped her weirdly. Yeah, it's really weird. It's a very obscure error. Okay, let me see if I can fix that. So set size to this, and then we're setting the angle to 0. Okay. Another thing I could do is it might be a problem with the collision of the wall. So it might be the wall collision that's causing the problem. Yeah, look how tiny it got. I really look how tiny it got. I have to fix. Yeah, no, I'm gonna have to fix that and look into that. But I definitely think it's a collision problem. Yeah, that's weird. Because, like, in this specific instance... Oh, no, it's still making her upside down. Weird. Let me... Maybe... Was it... No, because it's still... It was working before. So it only seems to happen when I'm... It's a very weird bug. Okay, so, like... If I'm against the wall, it... This is the fun part about game dev. When you're testing things, like Nancy is now like in the sky because she's anti-gravity. This is the fun part about game dev. You gotta kind of like mess around with it, and if I do, you really gotta test everything. Because like if you don't test things accordingly, you can get really interesting results. It's actually affecting both areas. And the reason why is because I'm actually like... So it only happens when Nancy is moving like this. And the reason why I don't think we had any issues with the library is because in the library, you're not really... In the library, you're not really doing anything that... Like, you're not changing Nancy's size. You're not messing with the sprite. You're not really doing anything that will impact the sprite itself. Like, you're not changing its size or anything. Where in the winter layout, we are actually impacting her size. They're next door. That's awesome. So let me. I'm trying to think about this for a second. It could be that... Okay, so if we edit the event sheet, so I'm setting her size to her current width minus 40. Okay, I actually know the problem of why small Nancy is not working. So I'm going to do 45, 45. So we'll make it a specific size. Okay. I think I might have fixed it. So I was running a formula that was constantly subtracting 40 and subtracting 40 and subtracting 40, and like Guava was saying, it translated too far and flipped the image. I think that's exactly what was going on there. So I was running a formula that was constantly subtracting to the point that it like messed up. So, and I think that'll fix it. I think Guava's got a point. Yeah, I see. Now it's no longer going upside down. So, yeah. So that definitely fixed it. And the only fix, so the fix that I made basically was that I have a hard-coded value for the size instead of a formula that constantly is subtracting. So that's basically what's going on there. And yeah, when it comes to game dev, you just have to constantly be testing things. So another thing I want to note here is the cloud that is in this scene is too big. So we have to make the cloud smaller because Nancy is outside. Yeah, let's see, the cloud is still too big. Is it even getting impacted? Let's check what's going on there. So we are going into the event sheet. We are create the thought bubble. Normally it does scale accordingly depending on specific instances. So I'm actually surprised that it's not scaling based on like my, yeah, it's weird. Because normally it does just create a new one based on the new. All right, let me see. Hold on. And now okay, I have to think about that for a moment, because if that's not the case, then what I'm going to have to do for this is I'm going to have to set it in the code, the size of the box, which is fine, which is totally fine. So what we're going to do now is I'll worry about that in a second. So what I want to do is I want Nancy to be outside, and then I want her to go here and have her appear in this library here. So something in the code is preventing that from happening. So if we go to the library and we work on it here. So as you can see here, Nancy's in the library. Let's go ahead and go outside. So what's happening here is we go back inside and then look where Nancy gets populated. So I want to fix that next. In order to fix that, what I'm going to do is on the start of the layout, we're calling the player position get set. What I want to do here is I want to, if the library, so the way it works right now is on the start of the layout, we are getting the player position, which is getting glob player X and glob player Y. If the glob player X and the glob player Y are 0, then we have it defaulting to the middle of the library. So in order to fix this, what we're going to need to do is make it so that we're going to have to fix that a little bit. Glob for global reminds me of slobs. That is funny, Glava. That is funny. So in order to make the room, to make it so that we're setting the library, one thing I could do is just make it so that on the start of the layout, you're just always being set to the middle of the room. Always. You're just always set to this position. And then if the X and Y variables for these are being, if they're both not equal to 0, then we can call the get function. So I'm kind of refactoring. So what refactoring means for coding is you're basically like re-editing your code. So what I'm doing is on the start of the layout, I'm calling the set library, which is that middle of the library, and then if the glob player X and glob player Y is 0, is not 0 is what I should say, then we're gonna call the get. So let me explain that again. So if I go here and then I go back, yeah, see, now it's breaking. Okay, so let me go to the input manager. If the player hits the E button, where is that code? So if the player is, okay, here. So if love it, love the emotes. Let me move this over to the controls. So if we're overlapping a hotspot and then the E button is down, we're gonna set the player position, which is right here. So we're setting Kenny Girl, I love that. Amazing redemption. Amazing. So set basically means we're setting the player's X value and Y value to Nancy's X and Y value coordinates. And we're doing that. And then we're running a hotspot clicked event, which changes the scene. So another thing I'm going to do is you danced in your living room off key. That's awesome. So what's happening there is it's setting the position of Nancy's X and Y coordinates, and then it's changing the scene. When we go, let's see. So what we're doing there is so then if I go back to the input manager and run the get, it's literally just setting Nancy's position to whatever glob X and glob Y was. Sorry. So one really cool thing about Construct is that you can do something called debug layout. And the way this works is that it shows you all this data. And one thing it shows you is my global variables, which is right here. Glob player X, glob player Y. So if I set to the fireplace, it's changing it to 658, 259. So if I go back, notice how it's still setting her back to the original position, and it's actually changing the positioning there. So let me go ahead and see that really quick. So set library. Okay, I know exactly what the problem is now. Okay, so what we need to do is on the start of the layout, what I want to do is if the global variables of glob player X and glob player Y are not equal to 0, then we're just going to call the get method. And that will set whatever it is. Else, we will do set library. Let's try that. There we go. So now it is working appropriately. If we leave and go outside, what I want to do now is I want to make it so that when you're outside, it sets it to this, which is like right in front of the door. But there's a problem. No, sorry. No, when you go from outside to inside, I want it to be like right here. So if you go outside and what I want to do is Okay, I'm thinking. So if we're in front of this hotspot, I have the bubble set to exit and then the scene set to library. Yeah, when you go into the room, Guava, it teleports Nancy like all the way over here, and I don't want that to happen because what that's doing is that it's basically setting the position the wrong way, and I don't want that to happen. So it's basically calling like the set outside of the glob, and that's not what I'm trying to do. So yeah, I'm just trying to figure that out for a second. All right. So Nancy goes in front of the hotspot. She clicks the action button. We're taking ourselves from the Winter Wonderland to the library. What I think should happen here is let's see. There's a few ways we could do this. So when the library scene loads, the glob values, player X and player Y, are already set. So one thing I could do for the hotspot is I could add a new instance variable that's a Boolean. For those of you that don't know what Booleans are, Boolean can only be true or false. It can't be anything else, just true or false. I could create a Boolean variable and call it like reset globs or reset POS globs, like position globs, and set it to false. I can also add a description here called reset position. And then if you notice right here, we have the actual like helper here. So reset position global variables, which is really convenient for us. And then you can also see your comments right there. So anyway, what I'm going to do is I'm going to set that equal to checked. And what I'm going to do is if the player has that checked, what I'm going to do is update some of my functions. So this hotspot clicked event, let's see. I'm going to have to update the function to add. I'm going to have to add a parameter to it and call it reset glob. We reset POS glob, setting it to a Boolean. Hit OK, and then for this part, I believe it just does it automatically, but I will check that. I will double check that because yeah, I'm not sure. Well, we're gonna double check that just to make sure. And then what I'm gonna do is we're gonna check the Boolean reset glob, and then I'm going to create a system level function that changes the variables. So set value of glob player X to 0, and then set value of glob player XY to 0. Let me go ahead and see if that worked. I don't think that worked. Okay, so what we're gonna have to do instead is I'm gonna have to remove this, unfortunately, and then I'm going to need to create. I'm gonna have to fix this a little bit. So I'm gonna have to edit this and change the data type to a number. You can fake a Boolean by making it 0 or 1. So instead of true or false, you can just do like 1 or 0. So I'll just make this a 1. And let's go ahead and jump back into that function again. So I'm gonna add a parameter again, make it a number, call it what was it again? Reset POS glob. And then the default value, we'll make nothing. We'll make, okay, for the default value, we'll make it 0. Is that what I called it? Reset POS globs. Okay. So then what I'm going to do is I'm going to go to the system here. I'm going to compare a variable and then do the reset POS globs. If it's equal to 1, which is technically true, then we'll set the blip positioning equal to 0, and the y equal to 0. And then let me go ahead and fix the function here. So there's a function call to hotspot clicked. I'm going to have to set this to the sprite hotspot dot reset position globs, and then this one is also needs to be fixed. Dot action. And then was there anywhere else that I call that function? Let's see. So that's just the function declaration. This also needs to be changed. So SPR hotspot dot reset globs. Okay. So now that we did that, if we load up the library scene, if the player X and the player Y is not equal to 0, then we call the get function, which is whatever is in here. Otherwise, we call set library, which sets that specific piece. Yay, it works. Nancy is no longer teleported to this side of the room. And yeah, so we were successful in our efforts with getting that to work. So as you can see, Nancy is back where she belongs in the beginning, in the actual room that she's in. Also, for some reason, now that I've been doing like a more zoomed in version, I feel like Nancy's speed is not fast enough. I'm gonna increase it to 400. That seems a little bit more zippier, because before she seemed not fast enough, and now she seems faster, which is great. So if we leave, we're now in this winter wonderland. Nancy's like, wait a minute, I thought I was in San Francisco. Where am I? So this is us in the winter wonderland, and Nancy is, she's back in Skiprot from Sea of Darkness. That's what's going on here. She's back in Skiprot. But let's do something about that like bubble, because the bubble didn't look right. So if we go to the input manager and we have this like bubble creation, let's see if we can fix something like that. So if Nancy collides with the hotspot, we're gonna create that bubble. But let's go ahead and create a blink sub event, and this is one way you can do it. Well, actually, you know what? I'll do it differently. So we're gonna add an event, and we're gonna look for that bubble. And I believe there is an event like where if it's in the room. Let me just check real quick though. Is on screen. So if the bubble is currently on screen, let's change the bubble's size. So we're gonna set the position of the bubble. Let's see. Set position. What's the bubble's current position? The current size of the bubble is 65 by 57. So let's do oh wait, we're not changing the position. I'm sorry, we're changing the size. So SPR thought bubble, that the actual size it currently is, we'll just subtract like 20 or something from it. And then we need to grab the property. I wasn't grabbing that property successfully, so we're gonna do thought bubble width -20, thought bubble height -20. If construct has been open for too long, it tells you that you should take breaks with it. I can totally see why. All right. Whoa. Okay, that was unexpected. Okay. I'm just gonna not play with the formulas ever again. Let's just do like 20 by 20. Alright, and that's too small, so we'll do like 30 by 30 and see if that's... Alright, that's a little bit, that's actually not bad. 30 is actually not bad. I don't mind 30. Always look deeper for clues. I need to like figure out my formulas. My formulas that are just never that great. Okay. I think 40 is I think that's a big enough size, because if you're in full screen mode, I think that's a decent enough size for this scene. Yeah, I think this is appropriate. So what I did was, just to recap, for this winter event sheet, if the bubble is on the screen, then we're setting the bubble size to 4040. And the reason why we did that is because if you're in the library, you're more zoomed in, so you can see the size in a bigger way. But if you're outside and you're further away and Nancy's further away from the screen, you want the bubble to be smaller. So that's why I made the bubble smaller. Let's say, for example, we wanted a bubble further away. Let's see how that would look. So let's try, instead of none, we'll do like shock, and just see how that looks. So that looks, I think that looks good. I think that looks good. I think that the bubble is still small enough that, or big enough that you can still see it, and it's big enough that, like, yeah, it looks, I think it looks good. So yeah, and then I need to fix that. So it's set to none, and then so I want to make it so that the animation gets changed. So let's see, because right now it's still showing the same one, regardless of. So in order to fix that, let's see, if Nancy's on a collision with a hotspot, then we create a thought bubble. So I think what's going on here is that it's not getting rid of the old bubble, I think. I can test that by debugging the layout. So so right now on the scene, there's the current thought bubble that's right there. And then if we were to have Nancy walk away, there's two thought bubbles happening right now. There's the thought bubble that has the animation frame none, and there's the thought bubble that has the animation frame shocked. If Nancy goes up a little bit, there's actually more animation bubbles that come up. There's two nuns and then one shock, and the shock still remains there. And then it's not until you leave the scene that they come back. So, and then you can actually create like an endless loop of bubbles. So that's something else I'm gonna have to like look into, because like notice how my bubble instances right here is at 21, and that's just from me walking back and forth and back and forth and back and forth into those bubble territories. So what I think I should do is I should look for my bubble instances, and I'm going to destroy all my bubble instances and then create a new one. I think that'll fix it. So if I go here, that's got the exclamation, there we go. So what I did was, to fix that, is before a bubble even gets created, we're destroying any bubbles that existed prior and then creating a new one. So and the reason why we do that is because if you're in a situation where hotspots are really, really close to each other, we want to make it so that that the hotspot removes the previous bubble, especially if hotspots are overlapping like that. Even if there's not a bubble to render, because none is still technically an option. So as you can see here, we have the exclamation point, and then we have nothing. So we were able to fix that. So yeah, we were able to make it so that Nancy can now walk around in this beautiful winter wonderland. We have Nancy switching between rooms. She's going outside. She's taking a nice breather. She's enjoying herself in this winter wonderland. We were able to change Nancy's size. We even have the swing animation for Nancy as she's outside. So yeah, I was able to I basically, so that YouTube video that I released last week, I was able to talk about all the pieces that I was able to do to get it to work, all the programming involved, all this stuff in order to get it to go from one screen to the next. So I'm really glad I got to do that. And then I created this backdrop, this winter backdrop, and I was able to show you all like some other new features, like creating a scene to go from one scene to the next, making Nancy tiny versus making her big again, and so on and so forth. So that's pretty much how I was able to do all of this. And that's the whole project. It's pretty straightforward. This project is PC ready, so if you were to create a PC game that used the WASD keys and the mouse, you basically have a ready, fully made top-down adventure game. One thing, I do have some disclaimers though. This was made for fun. This was made for just for fun situation. Please do not use any of the Her Interactive assets unless you get exclusive permission to do so from them for commercial purposes. This was just for educational purposes and for fun. It's not monetized or anything. I do plan to release this project, but I'm not going to be using any Nancy Drew assets at all. I will actually be replacing this background with a generic Office background that is free. So I will be releasing this project, but you will not be seeing anything related to Nancy Drew. Again, you'll be seeing like free images and free top-down assets. Specifically, like for example, like this winter asset that you're seeing here. This winter asset, as well as this pixelated woman with a brunette woman hairstyle. Everything was found on craftpix.net. As you can see here, craftpix.net is a fully free and premium game assets. They have tons of free stuff you can use for commercial use or for free. They have a whole like freebie section with tons of really cool stuff like pixelated artwork, billboards, animated stuff. They do have a membership. Their 1-year membership is $4 per month annually. Or sorry, it's $4 I think versus the $15 monthly membership. But the way it works is that you get all of their assets, unlimited downloads, royalty free. You get all of their content. This is not sponsored or anything, but this is just a really cool website that I recommend if you need sprites or if you need user interfaces. They have like zombie stuff, so if you want to make like the next Project Zomboid, they have like some zombie assets. They have tactical strategy game assets if you want to try making a strategy game. They have tons of stuff. They have cafeteria if you want to make like a cooking sim in Construct. They have lots and lots and lots of really, really cool assets. So if you are looking for some like really cool assets, I recommend checking out craftpix.net. And if you do use their membership, then all of this stuff is included. They even have ready-to-made GUIs you can use. That you can fully edit, so it's really convenient. It's really nice. I recommend checking this all out. They have like trading card game stuff, level maps, lots and lots of cool stuff. One thing I want to note, they even have like in-app purchases, like stuff like this. You know, if you ever download a mobile app and then you see like these in-app purchase icons for like money, you can download these icons for free. And like someone basically just like, you know, probably just downloaded this from a website, and then they ended up probably like putting it in their game, and they're like, you know what, we're gonna do this picture, and this is the $99 picture, and this is the $49.99 picture, and this is gonna be, you know, the $20 picture, and then they're basically some really smart developer is probably just putting it, you know, in their game, and they're charging all that money for it. Welcome on in, Esco. I'm currently doing a class for teaching people game development, but welcome on in. So yeah, I recommend craftpix.net. It's a really cool website. There's tons of amazing artwork you can find on here, and there's just so much you can find on here that you can use commercially for your own personal games. There's so much you can find here that's either paid or for free if you decide to use their assets. So it's really, really cool. I recommend scrolling through it. It's really convenient. There's a lot you can do with it. Another website I recommend is Pixabay, Pixabay. Pixabay is really, really cool because all of their images, all their videos, all of their music and sound effects and GIFs, everything on this website is royalty and stock free. You can use any of their quality content for commercial use. Depending on which pictures you go into, you may have to do attribution. So always check the attribution stuff. But I recommend checking out Pixabay. Artists always upload their content to this website, and you can include all of this stuff in your videos, your YouTube content, your Twitch content, of your commercial video games. All of it is free with the Pixabay license, and it's free. You can basically, check out all of their content. So I know they have like more like stuff like this, but if you go to illustrations and you look up like sprite, maybe not sprite, but like, let's try like car. You can see illustrations of cars and stuff like that. So if you wanted to like save it, you can, use these. You can use stuff like this in your games or your assets, and you can kind of mess around with the content they give you. So it's really, really cool, and Pixabay is really convenient. Welcome on in, Figgy. So so for those of you that are just coming into the scene, into the Twitch channel, we created, so last week I released a YouTube video. I released a YouTube video last week that basically, let me go back to my library scene. I released a YouTube video last week on my YouTube channel that basically talked about this little like top-down adventure game, like tech demo that I made for Nancy Drew, and it's top-down and it's fully realized, where you can basically walk around as a pixelated version of Nancy, and you can explore the message in a haunted mansion with one of her interactive's older assets. And today I decided to go through a programming tutorial of how to do this top-down effect and how to get it to work, and then how to get Nancy to move around and everything. And then for the second half of the tutorial, I had Nancy go outside in this free artwork. And what I did was I created everything all over again, and I basically have Nancy walking around in this beautiful winter wonderland. I even added a special effect where if you go to a certain spot, Nancy is able to get tiny and become small, so that she kind of like adapts to the environment that she's in. Not without its bugs, of course. Like, there are some bugs that we have to fix, but it is cool getting the chance to like see this fully realized version of Nancy, of this, well, I shouldn't even say Nancy at this point, like this brunette detective character walking around in her environment. So it's a pretty cool project. My plan is to release the project, and you'll be able to, if you want to try developing with the Construct 3 game engine, you can try messing around with it yourself. But yeah, this is the fully programmed top-down adventure game engine. And yeah, this tutorial will be available on my programming YouTube tutorials, and you'll be able to get the opportunity to check it out. Again, all the assets that I used were found from craftpix.net, and as well as Pixabay. This was the Construct 3 game engine. I was able to create this project with the personal version, which does cost money, but I believe you can use the free version as well. I will definitely try opening the project in the free version to see if it looks okay. But everything I did was, I definitely believe that everything I did could totally be done in the free version as well. So this is just a small project, one of many programming projects that I will be showing you all how to do, both in lots of different ways. And by the way, if you don't want to use CraftPix, you can also go to the Construct Asset Store, and the Construct Asset Store has tons of stuff you can use as well, both free and for a cost. So there are lots of places you can go to, and that pretty much summarizes the project. I'm gonna jump back over to chatting. So that was the adventure top-down and side-scrolling project. If you are in the mood to make an adventure game for your friends or family, or just personally for yourself, feel free to check out this tutorial and use everything I did. I will be releasing this project as well, with generic assets that have nothing to do with Nancy Drew, so that will be coming soon. But yeah, that was the Construct project for a top-down or side-scrolling adventure game. I'm very confident that if you were to take this project and run with it, you could probably make your own game with it. All the pieces are connected in place. You would probably have to add your own things like additional UI changes or music or all that stuff, but the basic controls are done, and it's pretty much like ready to go. But just want to say thank you all for coming in. Thank you for exploring this game dev tutorial with me. And yeah, this And thank you for checking out the beginning of the Yeti PNG streaming. This has been a lot of fun. I was able to, I'm actually going to do that really quick. So Reactive by YetiTech, this is the way I'm able to do this. So if you want to try PNG streaming, Reactive by YetiTech is a Discord widget where you basically create like a voice channel that's only for yourself, and then you upload inactive and speaking images, and you are able to create your own PNG streaming. So that's how I was able to do this. Guava created the character for me, and then I was able to get that set up. So that's basically how you would do it if you want to try learning how to do PNG streaming. I'll post a link in the chat, but it's basically Reactive YetiTech, and that is how you were able to create PNG streams if you don't feel like showing your face, or if you just want to have a character instead. It's really convenient and a lot of fun. Let me jump back into chatting again. So let's see. I'm gonna send you all to someone that's online. Let me see who is online tonight. Just for the programming streams, I turned off all raids. So if you tried to raid me, that's probably why. Only for programming streams, I turn off raids. So I use Streamlabs, but you can definitely use OBS as well. I mean, for this, it works both ways. I use Streamlabs OBS though. All right, let's see. Let me see who's online on Twitch tonight. Let me see who I will bring over to you tonight. Who is online tonight? On this beautiful Monday. On this wonderful Monday. Okay, I see who I'm gonna raid. I think I'm gonna raid this person tonight. They're pretty cool and they're fun to hang out with. So I think I'm gonna raid this person. Okay. Let me get that started real quick. So I'm gonna go ahead and raid Jermeath. He's a LGBT Twitch streamer, and he's currently playing The Sims 4. So if you'd like to join us for the raid with Jermeath, feel free to come and do so. He's really funny. He's a comedian. So let's go hang out with Jermeath. But I hope you all have a great night. Thank you so much for coming in tonight, and feel free to tune in sometime. I think Wednesday for the Trauma Center stream. We'll be doing some more Trauma Center New Blood, or no, Second Opinion. Sorry. But yeah, thanks again, everybody. Hope you all have a wonderful evening, and see you all next time. Yeti, Italian Gamer Joe, is signing off.